Good afternoon to all. I am Dr. Rashmi Shrivastava from IIMT College of Polytechnic. I am a chemistry lecturer and my today's topic is polymers. I want to tell you what is polymers. Everyone aware polymers. What are polymers? By definition, polymers are large molecules made by bonding a series of building blocks which are known as monomers. The word polymer comes from the Greek word for many parts. Each of those parts is scientifically called a monomer, in which the Greek means one part. Think of a polymer as a chain with each of the link a monomer. So you can study when the polymer, what are polymers? The polymer is a long chain building blocks and the block are known as monomer. So the monomer is the basic unit of the polymers. Now, the polymers are of two types. First is natural polymers and the second is synthetic polymers. First, I want to tell you about natural polymers. Natural polymers are of two types, organic and inorganic. Organic polymers play a crucial role in living things, providing basic structural material and participating in vital life processes. For example, the solid part of all plants are made up of polymers. These include cellulose, lignin, and various types of resins. Cellulose is a polysaccharide which is also a natural polymer, and this polymer is composed of sugar molecules. Lignin consists of a complicated three-dimensional network of polymers. Wood resins are also known as polymers and it is a simple hydrocarbon and its basic unit is isopyrene. Another familiar isopyrene polymer is rubber. Now come to the next, synthetic polymers. What are synthetic polymers? Synthetic polymers are proposed in different types of reactions. Many simple hydrocarbons such as ethylene and propylene can be transformed into polymers by adding one monomer after another to the growing chain. Polyethylene, which is a monomer and it is composed of repeating ethylene monomers, is an additional polymer. It may have as many as 10,000 monomers joined in long colloidal chains. Polyethylene is crystalline, translucent, and thermoplastic. It softens when heated. It is used for coating, packaging, molded parts, and the manufacture of bottles and containers. Polypropylene is also crystalline and thermoplastic, but is harder than polyethylene. Its molecules may consist of from 50,000 to 2 lakhs monomers, and this compound is used in the textile industries and to make a blaster change in the polymer industry. So the synthetic polymers are very useful. Now come to the table which we can say what basically polymers are the plastic industries block compounds and then we characterize or classify the polymers into the 5 categories in which first is its name, second is its functional group, which functional group it contains, third the blocking unit means monomer, which monomer is the basic part of that polymer, and the next its properties, and the next is uses, where it is used. Now we can say in the table that there are many types of polymers, its functional groups, and the blocking unit. As all we know, what are hydrocarbons? The hydrocarbons are those compounds which contain only carbon and hydrogen. And the hydrocarbons are the basic unit of the blocking units. As we earlier studied that the blocking units or the monomers are the hydrocarbons. For example, alkanes. Alkanes contain only carbon and hydrogen. In the slide, you can see that one is methane. It means one carbon and other element is hydrogen. Number two, ethane. Ethane is in ethane is two carbon atoms and other is hydrogen. Propane containing three carbon atoms, just like butane containing four carbon atoms, pentane five carbon atoms, hexane six carbon atoms, heptane seven carbon atoms, octane eight carbon atoms, nonane nine carbon atoms, decane 10 carbon atoms, 11 undecane, and 12 is dodecane carbon atoms. These are the hydrocarbons, and these are the saturated hydrocarbons. Now, hydrocarbons at room temperature. As we know, there are three states of material: gaseous, liquid, and solid. So, in the gaseous state, the blocking units are methane, ethane, propane, and butane. When these units, then you can say the polymer is in the gaseous state. As in liquid state, it is basically two types of either waxy state or semi-solid state. Melting point. As the length of hydrocarbon gets longer, the melting point grows higher. It means any polymer which contains more than 20,000 blocking units is having higher melting point. As you can see in the graph, as the number of hydrocarbons increases, the melting point is increases. What other materialistic property changes? All these properties are depend on the nature of the hydrocarbon. First is viscosity, the other is hardness, the third one is toughness, and the fourth is flammability. These are the four main important properties of the blocking unit or hydrocarbon, in which the nature of the polymer depends: viscosity, hardness, toughness, and flammability. Now, as we know, the hydrocarbon only contains carbon and hydrogen, and the bonding in between them is mainly basically it contains a covalent bond, ionic bond, polar bond, and van der Waals forces. As you can see, the natural hydrocarbon or the natural polymer. The natural polymer is the rubber tree. Its sap is sticky, viscous, and cozy. Vulcanization. Vulcanization is a process in which we can change a simple polymer into a harder polymer, which is very useful in industries, in rubber industries, in automobile industries, and other industries. You can say in this, the structure of the polymer is complicated. It is not in a long chain, but the long chains are linked with each other through a ethylene bond, or a oxygen and the other bonds. molecular structure of polymers. Basically, polymers having the linear structure, the branched structure, it is cross-linked and it is networking. Linear structure having high density polyethylene, which is known as LDPE. PVC, which is polyvinyl chloride, nylon and cotton. Branched having low density polyethylene, which is LDPE, cross-linked, which example is rubber, and the other networks are Kevlar and epoxy. As you can see, low density polyethylene, LDPE. LDPE means low density polyethylene in which the monomer unit is ethylene. You can see in the slide that ethylene having 2 carbon atoms and 4 hydrogen atoms which linked with another monomer by a single linear combination. And its example is a plastic sheet. You can use this to cover our vegetables and fruits and as household products. It LDPE contains the chain length is 1000 to 2000 hydrocarbons or the monomer units. Next is high density polyethylene or HDPE. HDPE in the example of HDPE is plastic bottles, plastic containers, buckets, tubs, and plastic bags which having high durability. It is a compound of monomer having ethylene, and the ethylene is the monomer unit. Ethylene also having 2 carbon atoms and 4 hydrogen atoms, but it is a long chain length having 10,000 to 1 lakh monomers. Ultra high molecular weight polyethylene. The short form, it is used as UHMWPE. Its chain length is 2 to 6 millions and it is used to make helmets, tires and hard plastic, hard rubber gaskets which having a very high melting and boiling points. Now, we can say in the polymer industry, there are endless possibilities to make new functional groups having new combination of hydrogen, carbon, silicon, boron, and other elements of the periodic table. Functional group, as we all know, we can use in the polymer industry many functional groups as a monomer unit, just like alcohol, phenols, thiols, epoxy, epoxides, ketones, aldehydes, dicarboxylic acid, esters, amides, amines, and nitriles. Many examples, many combinations of functional groups can use to make polymers more durable, more effective, and more useful in rubber industries. PVC. All we know, PVC is polyvinyl chloride, which is very useful in our polymer industry. It is a chain length having 4,000 to 5,000. Polyethylene terephthalate. Its common name is PETE and it's commonly we can say this word is polyester. Polyester and in short we can say polyester. The basic unit or the monomer unit of polyester is polyethylene tetraphthalate. The monomer unit of polyethylene tetraphthalate is a carbon and hydrogen compound which we linked with each other through a ester group. and its chain length is 4,000 to 8,000. It also consists terephthalic acid. Cotton. Cotton is a natural polymer and its basic unit is, its monomer unit is cellulose. Cellulose is the most common organic material and it is also a primary constituent of wood and paper. Polymers in biology. In our body, in human beings, animals, and all living things, the basic building block is DNA, and DNA is also a polymer. It is a natural polymer which is a genetic code to transfer one characteristics to another character, to one characteristic or in one species to the another species. And DNA is also a polymer in biology and it is a natural polymer. Another is sugar and the other is proteins is also a polymer. Inorganic polymers. Inorganic polymers means the carbon is replaced by the another element other than carbon, any hydrogen element when linked with any other except carbon element is known as inorganic polymers. The carbon is replaced by silicon, germanium, just you can see in this slide, polydimethyl germanium. In this, the carbon is replaced by Ge, means germanium. Germanium replaced the carbon linking and the germanium linked with each other to the methyl group. Another replacement of carbon is boron-nitrogen bonding. Boron-nitrogen directly linked with each other and it is a inorganic polymers example. Now, conclusion. Conclusion means overall you can say the polymer are the long chain compounds, organic compounds, inorganic compounds, natural compounds or synthetic compounds which is made up of, its basic unit is monomers. The nature of the polymer depends upon the nature of the monomer. So the conclusion is, first point is polymers make up all sorts of materials that are all around us. Our environment, our surroundings are made up of polymers. You can see around you many examples of polymer you can see and then set your mind which is natural and which is synthetic and what has been the monomer unit of that polymer. They can have a huge range or material properties based on their monomer unit. As we can say, if the monomer having the cross-link or long chain or branched, the polymer is having the character more durable, more long lasting and more hard. The main function of the polymer depends upon the first is the nature of the monomer and another is the functional group it contains, either alcoholic, amide, nitrile, ester, ethanol, whatever. Structure. Structure means either it is linear, branched or cross-linked structure. Third is backbone. The backbone of any polymer is, it's the Unit monomer. The nature of the monomer, the functional group which it contains, the linking between them, it all factors decide the nature of the polymer. Keeps thinking about how chemical interaction on the nanoscale correspond to material properties on the macro scale. These minor properties decided the nature of the polymer and where it is used and what is its properties. Now, thank you.